What we saw in the last video is that vertex form is great for finding a vertex. It's not so nice for finding intercepts, right? So, I mean, every form of a parabola gives us certain information, but vertex form is limited to whether it's up or down and what the vertex is. So let's just practice with that part of it. The vertex, make sure you're doing opposite of x for the sign, opposite sign for x, and then the same y. The y is the number at the end. But the x number, we have to flip. So in this case, x minus 1, the x is positive 1, y is negative 3. Let's go through and do, well, I guess we should go across. All right, upward or downward? That we look for A. Upward means A is positive. Downward means A is negative. That number in front of the parentheses. This one's positive, so it's going to be upward. The axis of symmetry is always x equals a number because it makes a vertical line. Vertical lines are always x equals a number. It is not just a number though, it has to be x equals. So in this case, it's x equals, and then whatever the x value is from the vertex, because the vertex is what's in the middle of our graph. All right, let's try the next one. Opposite sign for x, so that's negative 4. Same sign for y, negative 4. This one, the a value is negative, so it's going to be downward. And the axis of symmetry is x equals the x value from the vertex. All right, next one, negative the x value, opposite sign for x, so it's negative 41. Y value is the same. The a in front of the parentheses is negative, so this one's going to be downward. And then our axis of symmetry is always x equals whatever the x value is from the vertex. So hopefully these are making sense. Let's try it. Opposite for x, same y. The a is positive, so that's upward. X equals 2 is the axis of symmetry. You might want to pause the video, try the next one on your own, and then check with me. The vertex should be 5, 3. This one doesn't have an a, but that just means a is positive 1. But that's positive, so it's upward, and x equals 5 is the axis of symmetry. All right, hopefully those are making good sense. Let's try putting this together in a graph. So these are actually opposite, where they're going to give us a graph and we need to find the equation. So the graph is given. We're going to find the formula for the graph in vertex form. So vertex form, they write it right here. Y equals a times x minus h squared plus k. This one, the vertex is the point negative 3, 4. We can read that from the graph pretty easily. So let's put that into vertex form. The only thing though is that we do not know a. We have to solve for a. So we're going to plug in the vertex, then solve for a. All right. So y is just any, x comma y is the two variables, any point on the graph. A is what we're going to have to find. X minus, we always flip the sign for the x, so it's going to be x plus 3 squared plus 4. All right, so this is the first time we've gone backwards. We all see how I flip the sign for x, same y. Make sure it's squared. Sometimes that's a common mistake. If this weren't squared, then this would be the point slope form of a line, right? And we need the squared to make it a parabola. Now what we're going to do to solve for a is to use another point on the graph. Now it could be any point on the graph. The directions here suggest using this point. We definitely need a point that goes through the grid lines though. So It's either this point or this point, right? And I'll just go with what they suggest, -4, 1. But we need to find another point that goes exactly through the grid lines so that I know that it really is that point. What we're going to do is plug this in for x and for y in this equation. And that'll enable us to solve for a. All right, let's try it. So the y value is 1 at that point. A is what we're trying to find. X is -4 plus 3 squared plus 4. Make sure you're doing PEMDAS on this. I'm actually going to start, though, by subtracting 4 from both sides. That seems easy enough. So -3 equals a times -4 plus 3 is -1. -1 squared is +1. Oh, well, that isn't too bad. A is -3 because 1a is just the same as a. So after we solve for a, we need to put that all back together into where we started. So our equation, our answer is y equals -3 times x plus 3 quantity squared plus 4. That is the vertex form of this parabola. Now, a good check is that the a we found is negative and it's an upside down parabola, so that agrees with what we know. Let's try another one of these because they're definitely a little different. All right, we got a graph. First, identify the vertex. In this case, it's the point 1, -3. We're going to use that to write it in vertex form. So vertex form is y equals a times x minus h quantity squared plus k. So we put in our h and k from this vertex. So this time we flip the sign for the x, same sign for the y. That's our vertex form, but we need to use another point to solve for a. All right, make sure you find a point that goes exactly through the grid lines. I usually look and see if the y-intercept is something nice. We didn't have that for this graph above because we didn't know what the y-intercept is. This one, it's just the point 0, -1. So that's the point I'm going to use, but you could have picked any point that goes exactly through the grid lines. Like here's one, right? There's one over there, there. But, you know, y-intercepts are nice because there's a 0 in there for x. So I'm going to plug in this for x and for y, this point. So the y is -1, a times the x, make sure my x looks like an x. X is 0, so 0 minus 1 squared minus 3. I'm going to start by adding 3 to both sides because I remember the goal is to solve for a. So that's 2 equals a times -1 squared. That's another 1. They were too nice to us. If this had been something else, we would have just needed to divide both sides, right? It's just solving an equation, but this one is just a equals 2. And then last step, don't forget to then plug that into the original equation. So our answer, not the one with the h and k's, the one with the 1 and the 3. So y equals 2 times x minus 1 squared minus 3. Double check the a we found is positive and it's a right side regular parabola. So this looks good.